So for these three, we're going to use this graph off to the side. What is that the graph of? Position, velocity, or acceleration? Velocity. Usually when they give you a graph, it's velocity. When does the particle change direction? There's no work. We're just going to say at what time. So when do we have a change in direction? 3. Good. Positive to negative. Yes, please. All right, speed increasing, speeding up. So that's when velocity and acceleration are what? Same sign. So for this portion, do you see how we are above sea level? So velocity is positive and increasing. So acceleration is also positive. So that would be speeding up. So our first section would be from 0 to 2. Now I'm going to union because there's going to be another one. Or does anyone think they know what it is? Let me just throw that question out there.
3 to 5.
Good. It is 3 to 5. So for this portion, we are below sea level. So velocity is negative. And we are decreasing, so acceleration is also negative. What a lot of people will do is speeding up is going away from the x-axis and slowing down is going towards the x-axis. That's another way you can think of it. But yeah, 0 to 2 and 3 to 5. Cool. All right, using the same graph, this one's really weird. Again, I'm the messenger on this one. I'm giving it to you because I saw one like it on AP Classroom. We want to write an expression for the total distance from 0 to 6. I'm going to draw you a visual. I don't know exactly where we started because this is not a position graph, it's a velocity graph. But I'm going to call it x of 0. They use x on the quiz, so that's what I'm going to use. So x of 0. And then do you see how we have all this positive part above sea level? That means we moved what direction? Positive means we went right. So we're going to be over here until 3, we moved to the right. So our particle did something like this. Before I draw the next motion, because then we turn around, how could you get that distance? Again, I don't know what these numbers are. Like if it was from 7 to 12, you would say, oh, we went a distance of 5. You could just do that. But if you don't know what the numbers are, how could you figure out what that motion is? Like how much that distance is? Good. You would do x of 3 minus x of 0. Whatever that is, we don't know. We don't have the actual values. But if you subtract those, you'll get the distance that you went. Are you coming with me on that? I know that's very weird with the symbols, but we're going to put plus, and there's going to be another one because we turned around. So do you see how this is all below sea level? So that means we went what direction? Left until 6. So our particle turned around. And again, I don't know what x of 6 is. I don't know where that is. But all I know is it's that away. And how could I figure out that distance without knowing what these two numbers are? Now you would do x, because you have to do the bigger one minus the smaller one. So it'd be x of 3 minus x of 6. Whatever, when you subtract them, that gives you what the distance between them was. Again, I'm showing that to you because I saw one like it on AP Classroom. And those are the people that write the AP exam. So trying to show you everything. It looks weird, but it's not that hard. It's just subtraction problems. If you subtract these two numbers, you get that distance. And if you subtract these two numbers, you get that distance. Add it all up, that's your total. All right, this is going to be the last one that will be like a multiple choice question. After this, it'll be the free response. What did they give us for this one? Position. When is the particle speed decreasing? So for speeding up and slowing down, you need to look at both velocity and acceleration. All right, so let's get velocity, leave a little gap because we'll have to do some algebra, and we'll get acceleration. So what is our velocity function? Go ahead and do your derivative. That'll be what? 4t squared, good, minus 24t plus 32. Again, just leave a little gap. We're going to have to do some algebra. Go ahead and do the second derivative. The second derivative would be 8t minus 24. So these will all divide by 4. I'm going to do that just to make the numbers smaller. It'll look like this. And then we'll factor it. So that is going to split into what? Perfect. Perfect. And then this one, they both divide by 8. So I'm going to write it as t minus 3. So I'm going to make two number lines. I'm going to make one number line for velocity, one number line for acceleration. I'm going to start them both at 0 because we don't do negative time. And my velocity is going to have changes at what two numbers? Yep, 2 and 4. Yep, perfect. And then acceleration is 3. Do you see how I put them 2, 3, 4, like a number line? Okay, make sure numbers go in order. They're going to alternate, trying to save you some time and work here. They're going to alternate. Give me a number between 0 and 2. 1. When you plug that in here, you don't need to figure out the actual value, just whether it's positive or negative. 1 minus 4, negative. 1 minus 2, negative. A negative times a negative is positive, and they're going to alternate. Give me a number between 0 and 3. 2. If you plug in 2 here, 2 minus 3 is negative, and it'll turn positive. And I'm going to draw in my little balloon strings. At this point, I forgot what I'm doing. That's usually what happens to me after I get like deep into the problem. Like, wait, what on earth did they want? We want where speed is doing what? Decreasing. That would be where these are what? Yeah, opposite signs. So what intervals would we want where these are opposite signs? Yeah, 0 to 2 and 3 to 4. Perfect. Nice job. That's about as hard a problem as I can give you. That's a lot of work. It's a lot of algebra. It's a lot of interpreting what the question is asking you. That's about as hard as I can make it. All right, these last ones are going to be your free response questions. Position for particle m is this thing. Position for particle n is this thing. So we have two different particles, and they give us position for both. Your interval is 0 to 8. When, so it should be times, is particle n moving to the left? How do you do or figure out moving to the left? Yep. Velocity is negative. If you want to write yourself a little note. Sometimes it's a good idea because, again, if you're like me, if you get distracted halfway through the problem, then you can remember what you're doing. So first, let's get our velocity. Which particle was this? N. Okay, so make sure you look at the right one. N of t is this one. So our velocity will be 2t squared minus 14t plus 20. And we're going to do the same thing we just did in the problem above. Make a little number line for our velocity and find where it's negative. Those will all divide by 2. And so how is that one going to split? Yep, good, perfect. So this time when you make your number line, always start it at 0, but this one ends at 8. Remember to cap it at 8, because they actually did give us that interval. It doesn't go on forever and ever and ever. And then so we're going to need to put a 2 and a 5 on there. And again, it's going to alternate. You don't need to do every single section, and you don't need to figure it out the whole way, just whether it's positive or negative. So first section, let's try and plug in 1. If you plug in 1 to each of these, they're both going to be negative. Negatives cancel, so positive. And so then what's the answer? Yep, 2 to 5. And it looks like an ordered pair. It's not, it's an interval from 2 to 5. But I get that it looks like that. Letter B, when do the two particles travel in the same direction? That would be when their velocities are what? Yeah, the same sign. And again, this isn't necessary if you're like, yeah, I don't want to write that. I just think sometimes it's helpful to write the justification almost first. So then if you get partway through and forget what you're doing. So here's what we're going to do. We're going to do the exact same thing we did in part A for the other particle. We'll have our two number lines and we'll compare them and see where they're the same sign. All right. So let's get our velocity for the other one. I think this one involved trig, didn't it? Didn't have trig in it. Yes, it did. So what is your derivative of sine? Cosine. So it is going to be 3 cosine pi over 6t. But what rule is that? Good. So we're going to chain on pi over 6. Perfect. So let's make a number line, 0 to 8. Now, this one was real easy to tell. Oh, we needed to put 2 and 5 on our number line. This one's going to be a little tougher. You have to think about setting this equal to 0. I'm going to try and talk you through a little bit of this so you don't have to do as much writing. You set this equal to 0. 0 divided by anything is still going to be 0. So do you see how these parts are going to go away? Like 0 divided by pi over 6 is still 0. 0 divided by 3 is still 0. So I want you to imagine your number line. Cosine is the x part of the point. Where is the x part of the point going to be 0? I'm looking for a word like up, down, left, or right. Where cosine is the x number? Yeah, so up and down, 0, 1, and 0, -1. What is the up amount of rotation? Pi over 2. I don't think we're going to make it far enough to go to the down one. I think that's going to be off the interval. Let's see what this one comes out to. The pi's are going to cancel. And how do you cancel out a 1/6? This is basically like a 1/6 now. Yeah, times by 6. So if you multiply by 6 on both sides, what do you get over here? 3. 6 divided by 2 is 3. Trying to think, if you made it 3 pi over 2, 3 times 6 is 18, divided by 2 is 9. That's going to be off the interval. So all we need is 3. If you plug in a number between 0 and 3, maybe like 1 to this, if you plug 1 in, you don't need to remember what cosine of pi over 6 is. It's square root of 3 over 2. But it's going to be positive. You know what I'm saying? The other thing you can do is think of the cosine wave. Where does the cosine wave start? Okay, do you see how this part is above sea level? It's the other way you can think about that. Anyway, it's going to be positive and then turn negative. Now here's where this is a little bit tricky. Did I lose you? Okay, bless you. Here's where this is a little bit tricky. And again, this is why I write it down, because at this point I forgot what we're doing. What are we trying to find? Same sign. You have to compare this number line and this number line and see where they are the same sign. So what do you think? From where to where? All right, 0 to 2, they're both positive. I think there's another one. Is it 3 to 5, they're both negative. Or maybe that wasn't that tricky. You just kind of spat that out. I find it hard to look at 2 number lines like that. That seemed like that went okay for you. All right, is particle M speeding up, slowing down, or neither at time 5? So you need to look at both what? Velocity and acceleration. So let's do V of 5. You don't need to figure out what it actually is. In fact, I recommend that you don't. Just positive or negative. We already made a handy number line for both of them. Which one was M? Yeah, this one was, here, let me label. This one was N and this one was M. So for M, at 5, which is between 3 and 8, our velocity is negative. All right, so V of 5 is negative. We need to get our acceleration and then plug in 5. So let's look back at our velocity here. What's your derivative of cosine? Negative sine. So it's going to be -3 sine pi over 6t times pi over 6. And then you have to multiply by pi over 6. If you wanted to, and what I was debating how I was going to go through explaining it, you could have multiplied these together and just put that out front. What would be 3 times pi over 6 if you wanted to just put that out front? Yeah, that'd be pi over 2, 3, 6. So you could take this one and put it out front and call it pi over 2, and then see that this one is your second chain rule, but you did another derivative, so there was another chain rule in there. All right, if you plug in 5, sine of 5 pi over 6, I don't care what it is, just is it positive or negative?
Positive.
What? Let's go this. You're right, but I need to get everybody else there. What quadrant is 5 pi over 6 in? You all passed pre-calculus. Second quadrant, sine is the y value, and the second quadrant is y positive or negative? It's positive. So sine of 5 pi over 6, this part's positive, but then we're going to multiply it by a negative. So this is negative. I think on the quiz, I'm trying to remember. I can't remember everything in the world. I think they actually ask for a of 5 though. But real quick, if you had to actually write out what a of 5 is and it's free response, you would just recopy this and do what? Yeah, change the t to a 5. Do you see what I'm saying? Are you getting what I'm saying here? And like, that's the answer. Just don't do anything. Just put 5 in it. All right, so what's the answer to the whole thing? And we have to justify, so you have to write a little sentence. Oh, good. Speeding up. I love it. Speeding up at what time? At time 5, because you can abbreviate that. You say they will not give it to you. Because velocity and acceleration are, oh, you can say both negative. I like to say are the same sign there. Just because what if they aren't both negative? What if they're both positive? I like to stick with same sign or opposite sign, but both negative is valid too. So that boils down to personal preference. I like to stick with same sign or opposite sign. But you have to say the at time 5. I hate to tell you this, they won't give it to you. And there are no half points. Like this is worth 1 point. And if you leave off the at time 5, they won't give you that point. So just letting you know. Which is why I would be a bad grader, because I would be like, oh, yeah, sure, give you that one. All right, what were you given? Position, we want at rest. So what is at rest? How would we find that? Yep, perfect. Oh my gosh, all right, so we're gonna get the velocity, set it equal to 0. Again, some problems are gonna be hard. This one's not all that hard. I would call this an easier one, okay? Derivative, 24t squared minus, what is that? 42t plus 15. We're going to set it equal to 0. Those will all divide by 3, right? So I like to just divide to make the numbers smaller. 42 divided by 3, what is that? 14 plus 5. Oh, that's a fun factoring one. We haven't done one that has a coefficient in a while. You can split 8, either 1 and 8 or 2 and 4. What do you want to try? Yeah, I think it's probably 2 and 4. 5 is going to have to be 1 and 5. Do you want the 1 in the first parenthesis or do you want the 1 in the second parenthesis? First one, okay. Now let's see if we're right. Guess and check has 2 steps. Number 1, guess. Number 2, check. You have to actually check it. The outsides are giving you what? 10? Insides are 4. That adds up to 14. I always do the symbols last. What do you need to get a negative 14? Yeah, both negative. Cool. And so your times are 1/2. 5/4. 1/2 and 5/4. You're setting both of those equal to 0. All right, last one. Using that same equation, so the position here, what is the total distance traveled from 0 to 1? You're going to plug in 0. You're going to plug in 1, but there is another number you have to plug in as well. And we already found it. We just found it. What's the other one? 1/2. Why would we not need to worry about 5/4? It's past 1. It's past the end of the end. Good. Perfect. Nice job, guys. Now, as a heads up, it's not going to be fun to plug in the 1/2 or the 1. Sometimes, I've seen this, they make you do this without a calculator. So you have to power through and just not be a giver-upper, okay? Now, 0 is easy. If you plug in 0 to this, what do you get? 1. Oh, be careful with that. Now, plugging in 1/2. 1/2 cubed. What's 2 cubed? 8. So 1/2 cubed is 1/8, which is actually really good because 1/8 times 8 is 1. Let me talk us through that again because that sounded dicey. What's 2 cubed? 8. So 1/2 cubed is 1/8 times 8 would just be 1. All right, minus 1/2 squared is 1/4. So it would be 21/4. Don't worry about that. We'll figure it out. We're gonna have to power through. All right, plus 15 times 1/2 would be 15 halves, and then plus 1. Now, when you add fractions, you need a common denominator. Okay, 1 would be 4/4 minus 21/4 plus, good, nice job, guys, 30/4 plus 4/4. So this is going to be something fourths. You just have to add and subtract all those numbers in the numerator. I usually like do all the positive ones and then subtract the negative ones. 30 plus 4 would be 38. Minus 21 would be 17. Now there's nothing at all wrong with 17/4. But what would that be as a decimal? Because fourths, halves and fourths are pretty easy. Halves are 0.5 and fourths are 0.25 or 0.75. So 16/4 be 4.25. Good. I just feel like that's a little easier to deal with. We made it. You all survived. Good job. They do that sometimes. It's nasty. Mean. They're evil. I'm the messenger. All right, now we're going to plug in 1. That'll be a little bit easier. That'll be 8 minus 21 plus 15 plus 1. So again, I like to do all the positive ones. 8 plus 15 plus 1 would be 24. Minus 21 would be 3. So these are the results that we got. I like to draw the motion of it. I feel like that helps me. We start at 1. And then it goes to 4.25. And then it comes back to 3. If you don't want to draw that, it's not required. It's personal preference. I just feel like it only takes 10 seconds. And it helps you to see what's going on. It's like that other one where we did where it was like x of 3 minus x of 0. It's just now we have actual numbers, right? So how much motion was there the first movement that it did? Yeah, 3.25. So from 1 to 4.25 is 3.25 plus, and then how much motion was there in this second little bit that it went? 1.25 for a grand total of 4.5.